Maybe it's a very quick talk from Berger from CNRS, because it's rational decision making. It may be very quick. Loic. Rational policy making. Okay, we are very curious what it means. You have the floor. Thank you.
Yeah, thank you, André. So, so I'm an economist, and I'm working on decision making under uncertainty. And even though I was Christian PhD student, here I would like to discuss alternative views than expected utility to make decision under deep uncertainty. So I'm not going to present one paper, but I would like to have a more general discussion. And I would like to start with show you one paper that was published last year in Nature. The paper is called The Missing Risk of Climate Change. And here, if you have the abstract, what you can see is the author says the following. They say that the risk of climate change are enormous, threatening the lives and livelihood of millions of billions of people. The economic consequences of many complex risks associated with climate change cannot, however, be currently quantified. And the author argued that these unquantified, poorly understood, and often deeply uncertain risks can and should be included in economic evaluation and decision-making processes. And I think this illustrates quite well what I want to talk about here today. There are different notions, the notion of risk, the notion of deep uncertainty, and in particular also this notion that this unquantified risk, even if they are deeply uncertain, they should still be included in the economic evaluation or when we make decisions. And this is really the challenge now we face. How can we include those? So when we talk about climate policy making, well, there are different characteristics of a decision problem. Let's think about the policymaker. So first of all, of course, the consequences of the decision are global and long-lasting. This is widely known. There is also a long time delay between the moment the decision is taken and the effect materialize. Typically, when we talk about climate, this is clear. There are some potential irreversibilities in the physical system, so there is the potential of catastrophe. We touched this point just a bit, but we could trigger some tipping point and end up in a system which is completely different, yes. But what I would like to focus is the two last points here. So there is first, imprecise nature of the existing climate science knowledge. So we do not know everything, okay? There are a lot of uncertainties. And there is also this unpredictability of technological adaptation. We do not know how we will be able to adapt in the future. And overall, it means that the decision we have to make today, they have to be made in a deeply uncertain environment. And I'm going to discuss a bit more what I mean by that, but we need to make decisions in deep uncertainty, under deep uncertainty. So what is the challenge? Well, we do not know, so there are some limits to the understanding of the potential economic impact of climate change. And there are also different sources of uncertainty. So there are different ways to categorize them. One way is this one, so we can think about different sources. One is the scientific, which is really the relationship between the greenhouse gas emission and how this will impact the future climate. So this is more about the science. Even though we know quite a lot already, we do not know everything. There is another one which is important, which is the so-called socio-economic uncertainty. So how the climate change in the future will alter the economic environment, the opportunities we have, how it will affect the social well-being, so more the socio-economic part. And then there is what we could call the technological uncertainty. So this is about research and development that are made today, how it can lead to some viable technologies in the future. Okay? So one of the questions is also, which of these sources is the most important? Which one is of most concern so when we have to design policy, climate policy? So of course, you know that when you have to make a decision, you are faced with trade-offs, right? So in that case, what is the trade-offs that is related to uncertainty? So if you're a policymaker at the same time, you have, okay, how much weight, one of the trade-offs is how much weight you should assign to the best guesses and potentially bad outcomes, or the best guess scenario and the worst case scenario. So how do you assign the different weight? Another trade-off is, do we have to act now, or do we have to wait a bit more until we learn, and then we postpone the decision? So there is also this trade-off here. I have to make a decision under uncertainty. What's the best timing for this? Okay. So one quick remark also is that when we work as economists, as trying to advise also policy making, there is really this tension about the policy uncertainty, which is about, at the same time, we have some limited understanding of the mechanism by which the policy will influence the economic outcome. So we do not know exactly how it will come. And at the same time, there is this demand by the public and by the policymaker also for having precise answer. We want to know, they want to know what will be the effect of the policy. And us, we cannot always answer that. So there is always this tension when we confront uncertainty. So what I would like to do today is to introduce a very general framework that could be used, well, that we think is useful. And this framework, it will distinguish between different layers of uncertainty, which I will present now. But first of all, I would like to make it very clear from the beginning what I mean by risk, what I mean by uncertainty. So economists, in general, we make a distinction between uncertainty, which characterizes the situation in which we do not know the probabilities, and this is based on the work of Knight and Keynes, okay? And typically, there are many different terms that have been used in different literature. So sometimes it's called deep uncertainty, ambiguity, Knightian uncertainty, radical uncertainty, extreme uncertainty, etc. In that talk, all these, I put them in the same basket. It's just when you do not know the probabilities, okay? And this is defined in contrast with the notion of risks. Risk is really a situation in which I know the probability. The probabilities are perfectly known, okay? So I make this distinction and I will stick to that. Okay, and if you think about that, most even in real life, there are more of the first type. So there are very few situations in which you know perfectly the probabilities. Okay? There are different reasons for that, because we have too little information, because there are different predictions that exist, because there are different experts who can provide different assessment, etc. Okay, so most situations in real life are uncertain. Here, just a parenthesis also to really highlight the distinction. So the way we treat risk and uncertainty as economists is different than the way it is treated in the IPCC report. Okay, so economists and decision theorists treat them the way I just described. In the IPCC report is very different. So there is a very specific definition given by the IPCC. So this is given in the guidance note for the author. So a risk in the IPCC is the potential for adverse consequences for human or ecological system, recognizing the diversity of values and objectives associated with such system. And in this definition, there are different elements. So first of all, they recognize that this notion of potential, so the notion that there is uncertainty, we have some incomplete knowledge. The risk in the IPCC, it focuses only on adverse consequences, Okay, so only on negative outcome. Okay, so the positive one are called opportunities. And here there is no notion of quantification, either of probability or of consequences, which also make it a bit different than what we use in economics. Okay. A second point is that in the IPCC report, there is no rigorous distinction between known and unknown probabilities, or between uncertainty and risk, or quantifiable and unquantifiable uncertainty. And the reason is that the IPCC concept is mainly based on a heuristic approach that provides a description of different scenarios, while us as economists or climate economists, the approach involves some optimization. We want to optimize the welfare, some welfare indicators under uncertainty, and for that we need a bit more rigor, so to speak. Okay, so the framework I would like to propose is the following. So it's a framework that decomposes uncertainty into 3 layers. And this is not our framework. I mean, this is based on the work of prominent researcher, Massimo Marinacci, and the Nobel Prize Lars Peter Hansen. So they distinguish 3 layers, which are the risk, model ambiguity, and model misspecification. And I'm going over them one by one. So risk, as I was just mentioning before, it's just a situation in which you know the probability. The probability is objectively given. So here is an example, a very simple risk in which with a probability 50% I win, I get 1, and with a probability 50% I lose, I get 0. So you can imagine just tossing a coin. If you know that the coin is fairly balanced, etc., you know the probability, either you win or you lose. Okay? There is uncertainty. The uncertainty is about which state is achieved, okay, is obtained. Either you win or you lose. But the uncertainty is within a model. And here, by model, I mean a probability distribution. So this is a model, okay? So this model characterizes a risk, but this is a model, okay? And there is uncertainty within the model. And in that case, the probability is 50%, and this is important. It is objectively given, and it's a measure of randomness within the model. Okay? So this is risk. Now, in real life, it may happen that the decision maker cannot identify one single probability model, which corresponds to the phenomenon he's interested in. It might be the case that he's confronted, he has different potential models. So here's one model, I win with P% probability. Here's another model, I win with Q% probability. But I do not know which one is the correct model. Okay? Is it this one or is it this one? So there is a second layer of uncertainty, which is now the uncertainty across the models. Okay? And in that case, well, I could assign some probabilities to these two models. I could put a 50% probability by some law of symmetry, insufficient reason, whatever. But the point is that this, even if it was 50% here, it would be based on just on something different. It would be subjectively determined, which means that this would represent a measure of degree of belief I have in this model being the correct one. And this is fundamentally different than an objective probability. And this is what we will claim here. Okay. So there is also a third layer, which arise when the set of models that the decision maker consider may be misspecified. So I consider only P and Q, the two models, but in reality, it could be another one. So the correct model could be different than the model I was considering. And why does it happen? Well, because we know that in real life, model are necessarily simplification of very complex phenomena. And so we have to have this simplification, and potentially all the models are misspecified. Okay? But still, they are useful, but then we take into account that the fact that they are misspecified. So this is the third layer. Yes? The previous one? Yes? Yeah. So in that case, you consider that one of the two is correct. In the other case, you take into account the fact that the model, the set of model you consider may be misspecified, that it could be something else. But I'm happy to discuss, yeah. So what we claim is that this framework could be useful and is useful to analyze a vast majority of problems. And it certainly underlies many aspects of the economic climate system. Okay? And it also poses a significant challenge in the design of climate policy. And here I just have a few examples I would like to illustrate using some figure how we could see this as also using the decomposition. So this is a figure coming from the IPCC of the so-called TCR, the transient climate response. So I'm not a specialist, but it's an important climate parameter which very roughly tells you how much the planet will immediately warm when we reach the level of double CO2 concentration. And in that case, what you can see is that you have the PDF here, different PDFs, okay? So different probability distributions. So each of them represent a risk. There is uncertainty within a model, within a distribution. So, but what you have also is that you have different PDFs, different models. Okay, so you have also uncertainty across the models. And potentially none of them is correct. Okay, so here we really have the three layers, which is directly seen here. Another example is some scientific uncertainty about the potential catastrophes. And this is something I was working on a few years ago. So here what you have is the increase in temperature at the end of the century. Okay, and look that this is a reverse arc, so plus 6 degrees at the end of the century, plus 1 here. And here is the probability of a potential catastrophe, which is the collapse of the so-called Atlantic meridional overturning circulation, which potentially can have some important consequences. And here what we show is the different assessment given by different experts, okay, about what could be the probability given the increase in temperature. And as you can see, here at 1 degree, plus 1 degree, well, the experts tend to agree that the probability is very low, okay, 0 or just a few percent. Okay, so in that case, again, each expert assessment is a risk, it's a probability distribution. Then you have different expert assessment, different models. So there is uncertainty about which of the expert is correct, and then potentially none of the expert is correct. So you have also the third layer that is here. So in that case, of +1 degree is not that important, but what about here at +4? Okay, some experts say, okay, it will always be 0% is probability, but some experts say that it could be up to 60%. And as a policymaker, if you want to take this into account, what should you do when you have all this information coming? How should you react? I have a third example, but I think that for the sake of the time, I will go on. So what decision theory can tell us? So decision theory provides an axiomatic formulation of what it means to act rationally in the presence of uncertainty. And it provides some tractable ways to capture different uncertainty components in different environments. So the modern development in decision theory, this is based on Savage work, now they go beyond just the notion of risk, and they allow for taking a broad perspective of uncertainty by distinguishing different attitude or potential concerns for misspecification or for uncertainty across the different models. Okay? So overall, this decision theory, the modern decision theory, it opens the door to better understand or better conducting some uncertainty quantification that could be used both for private sector planning and government policy assessment. So it provides some tractable method to explore this uncertainty by distinguishing some attitude toward different layers. So the goal here, so when we have to navigate uncertainty, is to assess what is the impact of uncertainty on climate policy outcome. Okay, and one of the goals how to do that is to isolate some form of uncertainty, which one are the most consequential one. Okay? And so I think, I claim that by using this, we could use these models or the information that we have in a more sensible way than just discarding some of, just averaging them. How is it done technically or in practice with decision theory? So typically what we do is to assume some form of aversion, which means dislike of not knowing the probability. So we dislike uncertainty across model or dislike model misspecification. The way it is implemented typically target the uncertainty component, which has the most adverse consequence for the decision maker, and try to say something about that. What is the outcome? It's a kind of uncertainty-adjusted probability measure. Okay? So then there is the question, the question of rationality. And I think Christian this morning was telling that, according to him, there is no other way than the expected utility theory. I think, well, it's very difficult to get a definite answer to that. So certainly there is the EU view, the expected utility view. There it's forming some subjective belief. But according to that view, there is no distinction between the three layers I was mentioning. So that view considers risks, model ambiguity, and model misspecification in the same way. So it doesn't have the language to distinguish these different layers. While the alternative approach, the modern decision theory, can distinguish some attitude, it can distinguish the three layers and have specific attitude toward them. Okay? So, well, here I just would like to show that there are different views on that. Here is a book by John Broome. Here it's not even arguing for expected utility, but expected value. Okay, and just to show that there are different views out there. So here, what Broome was saying is that the lack of firm probabilities is not a reason to give up expected value theory. You may disperse and adopt some other way of coping with uncertainty. You may adopt some version of the precautionary principle. That would be a mistake. Stick with expected value theory. It is very well founded, and do your best with probabilities and values. This is one way to see this. Here's an alternative one, which was published in Nature Climate Change a few years ago. So what they say is that the selection of climate policies should be an exercise in risk management, reflecting the many relevant sources of uncertainty. Studies of climate change and its impacts rarely yield consensus on the distribution of exposure, vulnerability, or possible outcome. And hence, policy analysis cannot effectively evaluate alternatives using standard approach such as expected utility theory. Okay, so here, and they claim they also call for using alternative approach in the conclusion. So this is another way to see the problem. So here, just to mention also that I had the chance to work with prominent decision theorists on this. It was a few years ago during the COVID, but I think that the idea is really the same. There, it was really how can you make a decision when you have these different models? Okay, so when you have varying alternative models in front of you, and you do not know the accuracy of each of them, then in that case, what we claim, what we argue in this paper is that modern decision theory can be an essential guide in understanding what are the merits and limitations of different ways to confront uncertainty. Okay, so I will finish with this. So I think there's still open question out there, and this could we could discuss that together. So one of the questions is how much uncertainty aversion should we impose? Okay, there were already a debate, or not a debate, but between Frank and Christian about what is the risk aversion parameter that we should use, 2 or 4. Well, the same question would arise: what is the ambiguity? What is the degree of ambiguity aversion, or the degree of aversion to model misspecification, to model ambiguity that we should assign, and what would be normatively appealing? This is also, of course, one of the question. Another question is which source of uncertainty matter the most? Okay, and of course, what we could do is to activate this robustness concern about each source individually, and then compare when we activate all together. But I think that we also need to get a clear idea on that. Another question, and another open question, is really: do we have to do we follow this approach of probabilities like the one from decision theory, or more the scenario approach like the one promoted by the IPCC? So clearly, the decision theory approach, it faces some severe limitation, especially when we face a very complex and multi-dimensional problem or challenge. Then it becomes very complicated. The scenario approach, in contrast, well, you probably know the one with the SSPs, describes some alternative potential evolution of the world and estimate the consequences. And this offers some flexibility, simplicity. It's a if-then analysis. If we are in this world, this is what will happen. Okay? It's relatively easy to implement and to communicate. But then for us as economists, there is the big challenge is how the alternative scenario can be combined to derive this optimal policies under deep uncertainty. So how can we endogenize also the decision? Because what we will decide today will determine whether we are in this world or in this world. So just to conclude now, so I think that uncertainty matters when it comes for policy tools, when it comes to investment in green research and development, etc. So uncertainty matters. And I think this is important to understand what are the sources of uncertainty broadly conceived, okay? Both for the private sector and for government that wants to implement policy. Thank you very much.
We have some time, few minutes.
Thank you, Loic, for this nice presentation. I agree that real people do not behave like expected from the discounted expected model. The Ellsberg paradox explained that very clearly. But one question is to explain real behavior. The other question is should government be irrational in the way they evaluate their policies, or how do they determine their choice? If you believe that the probability of an event could be 1/3 or 2/3, you are not sure about that probability, but you put equal probability to these two plausibility. At the end of the day, I think it's a good idea to use a probability of 1/2 for that for the probability of that event. I mean, compounding probabilities is, I mean, you are here, we are here in Paris, the place of Blaise Pascal. I'm in Toulouse, the place of Pierre de Fermat. Compounding probabilities make a lot of sense at the end of the day. So I'm against using ambiguity aversion for policy making. I agree. People do not behave like that. They are unable to compound probabilities for rationality problem or inattention, but that's not reason for government to be rational.
So I think we agree that that it is irrational not to reduce if the probability are objective. But in the example you gave, the point is that then you would consider, following the expected utility, 1/2, and a situation in which you have the 2 experts or 10 experts saying this is 1/2, and a situation in which you have disagreement about experts. One is saying 3 out of 4, the other 1 out of 4. And the 2 situations in your example would be exactly the same, meaning that you don't have the language, or you do not conceive that in one situation there is agreement, in the other situation there is no agreement. And potentially this situation is more uncertain. And in that case, I would prefer a policymaker potentially who is more prudent, because there is uncertainty there. It's not the same situation. And expected utility does not have the language. It's the same situation for them.
Thank you very much for a very, very stimulating talk, especially at this hour. We needed that. One question, you talk about language and about the use of this as to inform policy making. I wonder whether there's indeed the sort of the modern decision theory and uncertainty can indeed be a language within which governments and also stakeholders within society can discuss, better discuss the policy, the different policy options they have, and better take into account the information they have on uncertainty. I mean, what you show is quite difficult to swallow. And I think part of the appeal of the scenario approach and the robust decision-making approach is that it's actually much simpler as a language for even for discussion and negotiation across stakeholders. So I wonder whether you have any comments on that.
Yeah, no, well, comment is just, I certainly agree, and the decision theory approach is really something difficult to swallow. I mean, in a sense, to get into that. But I think that if we can, at least, I'm not saying we should follow this decision rule, but at least if we can show that and use a bit the language showing that there is this uncertainty and that it matters, that it is important. And after that is the role of well, I understand that it's very difficult to communicate on that. Yeah, it's a good point, but no, I do not have that much to add on that. No. Yeah, I have to think a bit. Yeah.
I have a question very much related to Christian. It's a true question. So I'm really struggling if we should be ambiguity averse or not. So we have your 10 experts. Now, a natural idea is each expert has the same weight. Now, the ambiguity literature is going to say, oh no, because we need a layer of ambiguity version. So we're going to put extra weight on the most worried expert. And it connects to the precautionary principle, yeah, because like that is very bad, and this weather, we may have all these deaths. But then the outcome is going to be like a high carbon price. Now, that also leads to debts. So in a high carbon price, we're going to have like expensive energy. People will die from lack of air conditioning. You can have debts on both sides. So then I'm wondering if it's rational to put this extra layer, and there must be like a whole body of literature on that, and maybe also like disagreement. which you showed with Broom's citation. Is there guidance for my wandering?
There is certainly a literature discussing whether it is rational or not to follow savage axioms, so the expected utility, and Gilboa has contributed a lot to this literature. Of course, it's very difficult to come up to a conclusion. To prove that something is rational is very difficult. You can prove that, okay, people do not behave rationally and prove the opposite, that it's not in accordance with rationality, but proving in general that people behave. So there is this discussion, and in this debate, yes, Gilboa is claiming that, yes, the expected utility doesn't have the language to say, I don't know. And sometimes we may want to say, I don't know. Okay, in climate, there might be instances which we just do not know, and we cannot assign probabilities. And then assigning just probabilities because we need to, in the expected utility, this might also be debatable, whether questionable. Is it the right approach? And expected utility does not have this language to say, I don't know. And if you don't know, then of course the question is, what do we do? But if I don't know, yeah, I would prefer that we act potentially more precautionary, or that we take this into account, the fact that I don't know. I would like the policymaker to behave that way.
If I may allow myself a last question, very quick, but because I try to anticipate rational, for me it's a little bit different. I don't say what your definition is not correct, it is, but you may also say, well, I am strategic. So the fact I speak, I don't speak, I tell the truth, I don't tell the truth, okay, it's part of the game. And we cannot say that in 2029, all the things you see on internet and even in articles. I don't say people are lying, but people funding you and you cannot say something. Forget about say something. So, and this is part of the game. So this is the information, at least the general public, including us, we have to play with that. So is there some research on that? Game theory, strategy, of course, in game theory you do that, but related to your topic, the right to become silent, for example, nice article in Econometrica. I don't speak, I am very strategic, and you infer because I don't think that I know things. But in your context, is there research?
About climate, I don't know, but certainly there is some literature on how we can use ambiguity in a strategic way. Yes, certainly.